In this difficult problem, we're given that a list T consists of 30 positive decimals, and none of them are integers. And the sum of these decimals is S. And then they give us this estimated sum where they tell you exactly how to change those decimals. For example, if the decimal was, say, 2.8, where the 10th digit was even, is rounded up, which means this would be made 3. If it was odd, say 3.7, that would be rounded down to 3. And they tell us that in this set, out of 30, 1/3 have 10th digits, that is even. So 10 are even, 20 are odd. And the question is, which of the following is a possible value of E minus S, meaning estimated? So the difficulty with this problem is, I think, especially when I started thinking about it, I'm thinking of all these cases where the decimals are like this. And that, makes it seem really complicated. And I sort of abandoned that, and I said, well, let's just look at the simple cases where it's just one decimal. Because if you look at the answer choices, they're all whole numbers. So best to start with those examples. And I said, let's just assume the same decimal. So for example, the 10 even, they could be, for example, all those numbers could be, say, 3.2, or I'm just going to consider some possible examples, 3.6, 3.8. Here they're all even. And let's say here this is 5.1, 5.3, 5.5, 5.7. In fact, actually, I'm just going to make them 3.1, 3.3. Actually, it doesn't matter. I just realized. And then we have 3.9. So if in the case where we have evens, these are going to become 4. This is going to become, rounding it up, 4, 4, 4. And these would be rounded down. So those would be 3, 3. They're all going to be 3. And what we need to do is to find some of the possibilities. So what I'm going to do is, let's start with this first example where all 10 are 3.2. And these would be rounded up to 4. So the difference is essentially between these is 0.8. So the estimated sum, the contribution from the even, this would go up. And there are 10 of those. So it's going to go up by 10 times 0.8, or 8. Whereas the 20 odd ones, if let's say it's 3.1, goes down to 3, they decrease by 0.1 each one. And here I'm assuming that all the 20 odd numbers are 3.1. So we have 20 of those, multiply that by 20, so that's 2. So that's going to decrease it by 2. So it goes up by 8, goes up, this goes down by 2. So the net change here is 6, meaning that the estimated sum would exceed the sum by 6. So 6 is a possibility. Now we're given these 3 choices, and we have to sort of narrow it down. So what I'm going to do is to list all the possibilities and see if I can get to the numbers that are given in the choices. So this is the most direct way I thought of doing this problem. So even, as I said earlier, would be, say, 3.2, 3.4, 3.6, 3.8. So here we have 0.8, and then it would go up by 0.8, 0.6, 0.4. These are different cases. And then this is 0.2. And I have 10 of these. So the sum can either go up by 8, 6, multiplying each by 10, 4, or 2. Now with the odd, say 5.1, 5.3, 5.5, 5.7, 5.9, the sum is going down by 0.1, 0.3, 0.5, 0.7, 0.9, and there are 20 of those. So the net change actually would be decrease here is 2, 6, 10, 14, and 18. And these are negatives. So we have to see, is their combination, can I get to minus 16, 6, and 10? Well, if I pair this with 2 with minus 18, that gives me minus 16. So minus 16 is possible. I can form 6 with minus 10 and 4. So actually, I don't need minus 6. I need plus 6. So I would have to look at 8 and minus 2. That would give me plus 6. So I can do both 1 and 2. Question is, can I do 10? Plus 10, but you'll notice here the most I have is 8, and these are all negatives. So I can't really get 10. So the answer is just 1 and 2 only, which is choice B. So just to recap, it's a difficult problem, and I think the best way that I at least thought of, and I'm talking about it under exam conditions, is to think of a simple example. That's what came to me the easiest. But if I hadn't been able to see this, to be honestly, in the exam, I probably would have skipped it. And that's usually sometimes you have to do with the very difficult problems. But to recap here, the answer is B.